Guys, welcome to my channel. Today's program is about evaluation of Lisp style mathematical expression. Lisp expressions. Lisp is an expression oriented programming language. Lisp expressions are written with its elements separated by white spaces and surrounded by parentheses. 4 arithmetic operators will be implemented to evaluate math expressions: multiplication, division, subtraction, and addition. Example expression: parenthesis start, plus operator, 1, 2, parenthesis close. This is a Lisp expression. It has 3 atoms, plus, 1, and 2. Operations. Addition operator. Addition operator will operate each of its operand and calculate the sum of all the operands, a plus b plus c plus d. And if there is no operand in the expression, it will return 0. Subtraction operator. Just like addition operator, subtraction operator will return the subtraction of all its elements. It must require one operand. So if the expression is parenthesis minus a, it will return minus a. Multiplication operator. Multiplication operator computes the product of all its elements. A multiplied by b multiplied by c and multiplied by all the subsequent operands. Parenthesis product multiplication operator will return 1. It does not require an operand, just like addition operator. Subtraction operator requires one operand. Division operator, just like subtraction operator, division operator also require one operand, and it will return 1 divided by the operand. And in this case, it will return the division of all its operands. Now the agenda. I am going to implement 2 classes. Number 1 is the token class and the second is the expression evaluator class. In token class, we will have these 3 fields: operator, operand, is operator. Constructors, 2 constructors, one takes operand and other takes operator. And for the methods, apply operator will compute the arithmetic operation, and it takes 2 operands and return the result of the operation. Get identity. This method will return the identity of the type of operator. Takes no operands. This is a Boolean function that will return false for subtract and minus because they require one operand, and true for multiplication and addition because they require 0 operand. Is operator function to check if this token is an operator or an operand. Expression evaluator class. This class will evaluate the expression. This class will use stack to store the expression and local calculations. There will be 3 main methods. Is balanced method. This will check whether the Lisp programming expression is properly formatted. And balanced. Balanced in the sense of parenthesis because it is parenthesis delimited expression. Double evaluate expression. This will evaluate the entire expression. This will be the helper function that will evaluate the expression within a single parenthesis. Let's begin, guys. Thank you. Hello guys, let's start coding. I have created this skeleton program, and this is our main method that will test the code that I will create for the expression evaluator. So these are our sample expressions that we will test when the code will be ready. These are proper Lisp mathematical expressions, and these are the results. The test code will create the expression evaluator class and then run each of these expressions and display the expected result and the actual result. Okay, now let's begin coding. First we will write token class. This is the basic class for our application. So as I discussed in the details, there will be 3 fields. Then we will write functions, and before functions we will write constructors. Okay, so we need 3 fields: private, string, operator, private string, double operand, and private boolean is operator. This will show this token is operator or operand. Okay, we need 2 constructors: public token string operator, and we will set the operator and operand is equal to 0.0, and this dot is operator is equal to true because this is initialized here. Okay, second constructor public token double operand. This will set the operand and initialize the is operator to false. This dot operator let's change this one to character. This will be easier to check for empty, and operand is equal to this dot operand is equal to operand, and this dot is operator is equal to false because this is type of operand, not, and this will keep track of is operator. Now the functions. We need a function that will operate the mathematical operation. Public double apply operator, double say left, double right. Okay, double result is equal to 0, return the result, and now we will operate based on the operator. Switch operator, case subtraction, result is equal to left minus right and break. Case addition, result is equal to left plus right and break. Case multiplication, result is equal to left multiply right and break. And case division, result is equal to left divided by right and then break. And we will return the result. Okay, next we need identity. Public and double get identity. Okay, this function will return 0 for plus and minus operators. If operator is equal to minus or operator is equal to plus, return 0. Otherwise, for multiplication and division, return 1.0. Okay. Now we need a function to check whether the operator stored within this class it requires an operand or not. Public boolean take no operands. Okay, in case of multiplication and addition, we return true because they do not require an operand. If operator is equal to plus or operator is equal to multiplication, we return true. For division and subtraction, return false because they require at least one operand. Return false. Okay, now our flag function, public boolean is operator, return this dot is operator. Okay, now we get the operator from this class, public and character get operator, return this dot operator. And the last function, operand, get a function for the public character get value that is stored within the, and it should be double, return this dot operand. Okay, this class is complete now. All the getters are there and operational functions are there. Very simple class, and this is main important method that will operate a mathematical operation on two operands. Now this is our main class. This class will implement three functions. Is balanced function, evaluate local expression, and evaluate complete expression. These three functions, and we require stack, so we import it. Import java.util.stack. Here we need operation stack and token stack. So stack declaration, private stack object token stack. And for the operation stack, public stack double operation stack. Okay, let's begin with is balanced. Public boolean is balanced, and we take straight expression check balance of Lisp expression. Okay, so we need two local stacks, stack character, stack and new stack, stack string oop stack. Okay, these two will be used in stacks for evaluation. Okay, now length of expression, expression dot length. We iterate for is less than length and I plus plus. Get the character. Char C is equal to expression dot char at I. Okay, so we will check character by character. So first thing, if opening parenthesis, if C is equal to this one, so what we will do, push, because there are embedded opening brackets, stack dot push C. Next, increase the counter I plus plus so that we can check the next character. Okay, get the next character. C is equal to expression dot char at I. Okay, now if this is again opening bracket, opening parenthesis, so we will do that, do the same, push it to the stack, push C. Check, we need to check it first. If C is equal to opening, so stack dot push C. Okay, we stored it. Now check if there are more characters left. Else if I is greater than or equal to length, or not is operator, and next character is not an operator. Okay, we will write this function shortly. Return false. This is not a valid expression, because after this we must have a operator. After every opening braces we must have an like this, opening parenthesis and operator, opening parenthesis and operator. Every opening parenthesis must be followed by a operator. Okay, now next, if this one is a, if the next character is a operator, if is operator, what we have to do, we check which operator is this. if C is equal to or C is equal to subtract, because these two must require one operand, and expression dot char at I plus 1 is equal to this one. This will handle this case like this one. Parenthesis open and there is an operator and immediately it is closed. It is only allowed for plus and multiplication. For subtraction and division operators, there must be one operand at least. So if this is the case and it is immediately closed, so this is invalid. Return false. Okay, if this is not closed and next is the operand, push it to the OOP stack. So OOP stack dot push string dot value of C, store the operator. Okay, next, this is end of opening parenthesis. Okay, now if it is not, the character is not an opening parenthesis, so it is an else if is operator C. So what we will do, push it to the OOP stack. And if string dot value of, and if this is a white space, continue, else it is a operand, is digit C. So what we will do, parse all the numbers, string number, and we will keep on iterating. Num plus C and I plus plus, and read next character, expression dot char at I. Okay, now we will push the number to the OOP stack. Okay, now check here if it is closed. If we see the C is equal to closing parenthesis, so in that case we need to check stack is empty. If stack dot is empty, return false, invalid expression, because we must have something on the stack. Clear the OOP stack. and pop up the stack. And in case of white space, continue. Okay, now we check on the outer loop. If else if c is equal to closing parenthesis. Same thing that we did here, we can copy. Okay, reached here, return true. Our expression is valid. Okay, let's test this function. Let's write with small function. Utility functions. Private boolean is operator char c. Return c is equal to plus, rc is equal to minus, rc is equal to multiplication, rc is equal to division. Okay, private boolean is digit char c. Return character dot is digit c. Our helper functions are done. Okay, we can test this function here. Okay, let's say we close this one. And we print the result. Let's say s out f percentage s, and let's say percentage s exp eval I object dot is balanced exp eval I. Let's run this. Let's add new line. Okay, these are our expressions, and this is true and this is true. It means these are, all of them are balanced expressions. So our function is working fine. Okay, let's uncomment it and let's write the other two functions. Okay, close this one. Public double evaluate string expression. Okay, first thing first, let's say we throws runtime exception. Okay, check for balance. If is balanced expression. Okay, if not, we throw new runtime exception, invalid expression found. Okay, reached here, we start scanning, scan the expression. So scanner, let's import it first. Import java.util.scanner. Scanner is equal to new scanner, and we pass expression. Okay, set the delimiter, and there is a possibility more than one consecutive spaces, so we will pass a regular expression. Scanner is equal to scanner dot use delimiter, and pattern is S multiple, more than one space. This is very useful regular expression. Okay, now we will scan it. While scanner dot has next. Okay, so we will parse operand. If scanner dot has next int, we will parse multiple digits. So stringed, let's say pattern or data, let's say data is equal to scanner dot find in line, and we will get all the consecutive integers digits and push it to the token stack. Token stack dot push new double dot parse double is equal to data. Okay, this section will parse the integers. Now we will parse the other things. Else string a token is equal to scanner dot next. Okay, we will get first character. Char token is equal to our token dot char at 0. This is helpful for variable handling the variables. Okay, now if it is opening braces, if opening parenthesis, if token is equal to, so what we will do, continue. Okay, otherwise if it is an alphabet or a variable, character is alpha, token, this will help read a variable value. Read variable value from the user. So scanner reader is equal to new scanner system.in, and token stack dot push reader dot next double. Read from the user and push it here and close the reader. Okay, now it is not a variable and it is not a opening parenthesis or it is not a operand, so it is an operator. Else if token is equal to an operator, token is equal to and token is equal to plus operator. So we will push it to token stack dot push string dot value of token. Okay, now handle the token is equal to closing parenthesis. So what we'll do, we will evaluate. This will handle local expression. Okay, now else scanner dot close. It means there is something wrong. Throw new runtime exception invalid expression. That's it. Okay. Over expression has been scanned. Now what we will do, check token stack size should be 1. If token stack dot size is equal to, let's say, is not equal to 1, it is an error. So we will do scanner dot close and throw new runtime exception invalid expression, because at the end of the expression evaluation there should be only one value. And return do we have result here? Okay. Double result 0. Okay, and the result is equal to double dot pots double and token stack dot pop dot to string. Okay, and return the result. This function will evaluate our complete expression. Now we will need to write this function. This function will evaluate the local expression that we will encounter within the parenthesis. So public, let's say private void evaluate. Okay, we don't need any parameter for this because we are already storing the values into stacks. So double result and string operator and boolean is number, let's say true, and token is equal to null. Okay, now we will do while is number. We will read till we encounter a number. So operator is equal to string dot value of token stack dot pop. So we will pop a operator from the top of the token stack. Okay, next try double number double dot parse double and operator. Okay, catch number format exception NFE, and we set the is number to false. It means we pass this value. This value is not a number. Finally, if operator is equal to and operation stack dot size is equal to 0. So what we will do, operation stack dot push 1.0. It will handle the multiplication operator with 0 operand. Okay, this parsing is complete. Now the next, handle plus and multiplication operators. If operation stack dot is empty, so we will pass a token, new token operator dot char at 0, token stack dot push token dot get identity. Okay, next we will do return from here. If operator dot equals plus or operator dot equals multiplication. So create token, parenthesis close, and token is equal to new token operator dot char at 0. Next is result is equal to operation stack dot pop, while not operation stack dot is empty. We will iterate within the parenthesis and loop for all the possible operands. Double right is equal to operation stack dot pop, and the result is equal to token dot apply operation result and right. This will do the arithmetic. Now else if operator dot equals subtraction. Okay, create token operator dot char at 0 and pop the first operand, operation stack dot pop. Okay, check if empty. If operation if operation stack dot is empty, result is equal to token dot 0.0 and result. Otherwise, if it is not empty, then iterate all the operands and do the operation. Double write operation stack dot pop and operation result token dot apply result and write. Now the last one, else if operator dot equals division, token is equal to new token, operator dot char at 0, result is the first operand, the same way check the size. If operation stack dot is empty and result is not equal to 0, result is equal to token dot apply and 1.0 result. Single operator. This will do this case with subtraction, and subtraction requires this one. This is exactly same thing, operator operand and parenthesis close, means there is only one. If there is only one, we will return in case of 3 we return 1/3. Okay, next, else there are operands. So what we will do, we will operate operation dot empty. Pop the operand and set to the result, and this is the result and write. This will do the continuous, and here we will do result. Result is equal to operation stack dot pop. This will be last value in the stack, and we push token stack dot push result. Okay, this is our local operation for the expression within a parenthesis. Okay, let's test now. Go back to main function, and we already have everything set up here. This section will test the evaluate function. Test evaluate function. We will print the expected result and actual result. Let's run it. Okay, we already have seen this thing that will check the balance of the expression, and these are the expected values and the actual results. and this is accurate solution. These are our expected values. This is all the code for the evaluation of mathematical Lisp based expression. Thank you guys. Please subscribe to the channel to encourage the content and share the videos. Thank you. Have a good day.